Hello, in this first exercise for graphics and sound programming, we will just present an oscillator. We'll talk about oscillators. An oscillator is a synthetic sound generator, so we'll see how to create one. But we will start with some basics of P5.js. So when you open P5.js and you log in, you will be presented with this kind of default code, and the default code comes with a random name. We can change the name here, so I'm going to call this exercise 1 oscillator. I press enter. And the default code consists of two functions, a function setup and a function draw. The function setup only runs once when you start the program, whereas the function draw runs 60 times per second by default. So the frame rate or the frequency of P5 is 60 frames per second. So the setup basically creates a canvas of 400 by 400 pixels. So when you have these pairs of pixels, the first pair is the X or horizontal value, and the second is the Y or vertical value. And then in draw, you have the color of the background. So if you press play, in the right of our screen, in the preview area, we preview our canvas. And well, this is what you see is 400 a square of 400 pixels by 400 pixels. Okay. So what we can do is to for example also print things to the console. So the console is this area here on the bottom that the user will not see, but that as developers can see to do some debugging. So for example, to get the frame rate of in P5. So if you have any questions about reference, about the code, you go to the p5.js reference page. So when we're in P5.js, that's achieved by going to the reference item in the menu. And if you want to know more about frame rate, you just type frame rate here in the search field, and you can set a frame rate, or you can use the frame rate function to obtain. So calling frame rate with no arguments returns the current frame rate. So how do we print things to the console? We just specify print, we open parentheses, and we say frame rate with capital R, and then parentheses, parentheses, close the parentheses of the print, and always semicolon in the end of the line. And if we press play now, what we see is the frame rate, which is on average 60, sometimes depending on what else is happening in your computer. For example, in my computer, I have screen recording software going on. That will affect how your computer runs, but P5 will try to keep it at 60 frames per second. So I'm printing things to the console. I'll stop now, but nothing is happening in my preview window now. So what does this number? So I just commented out the frame rate. To comment out, meaning that we will transform this into a commentary, which is code that is not executed by processing. We just add // We can use commenting also to introduce our own commentary to the code. So background 220. What does this number 220 mean? Well, this is a color value. And colors in many computer applications go between 0 and 255. So there's a range of 256 or 256 possible values. So if we press 0, the background will be black. And if we put 255, the background will be white. So basically we're setting the pixel value. And this is grayscale color. When you have only one value, it means black and white. So it means a range of grays, basically. So it's a grayscale. Whereas if you want to create a colorful value, then we use RGB parameters, where R is red, G is green, and B is blue. So for example, 25500, this would be a red background, right? Whereas 00255 would be a blue background. So this relates to bits, and we call 3 channels. We call these color channels, and each channel, it's 8 bits or 1 byte of color. And this 255 comes from the hexadecimal representation. You probably saw this in HTML color, where you have 00 being black and FF being white. And for example, red would be FF0000, where each pair of digits is the hexadecimal, where FF equals 255 in hexadecimal. So let's draw something on the screen. Let's imagine that we want to draw a circle in the center of the screen. So we have a command to draw circles, which is the command is circle, and then we open parameter. We open the parentheses to add our parameters, and circle accepts 3 parameters. Let's take a look at circle. And it's the X value, the Y value, and the radius. Okay. Sorry, the diameter, not the radius, but the diameter. So the diameter then means twice the radius. So what if we want to draw, so if we want to draw it in the top left corner, that would be 0, 0, and let's say our diameter is 50. There you go, then the circle is drawn in the corner. What if we want it in the middle of the screen? So the middle of the width of the screen is determined by the term width, and the height of the screen is determined by the term height. So if we draw it here, it will be in the bottom right corner, right? And if we divide both of these numbers by 2, then it will be drawn in the middle. What if we want this circle to follow the mouse? Well, then we need mouse values, and we have something called mouse X, which allows P5 to track the current value of mouse X. Right? So if we replace this by the first value by mouse X, and the second value by mouse Y, we have a circle that follows the mouse, which can be quite useful. So we'll be using these numbers a lot, height and width, to draw something proportional to the screen, and mouse X, mouse Y to draw something that follows the mouse, or to have values that are kind of proportional to the mouse. Okay. What if we want a circle to only follow the mouse when we press the button? Well, then we need a condition. We're establishing a condition, and with conditions, then we need the if clause, where the if clause starts with the word if, and then you open parentheses, and you establish which condition do you want to track there. So the condition here is the mouse being pressed. And there is actually, in the reference, there is a mouse pressed function that is quite useful for us. So either we create a mouse pressed function like this, or if you want to check if the mouse is pressed or not, there's actually something called mouse is pressed, which is a property. So the difference between the functions and the properties is that the properties do not have the open and close parentheses just followed by that, whereas methods have. So print is a method, but mouse is pressed is a property. And this property is actually a Boolean, meaning, so it's a Boolean system variable. So meaning mouse is pressed will be true if the mouse has been pressed and false if not. So we can use that here in our condition. If mouse is pressed, close parentheses, open curly bracket. So in an if statement, the curly bracket, the first curly bracket after the if statement means the then. So if the mouse is pressed, then do something. In this case, draw the circle. And after we have the command that we want to execute, if the statement is true, we close the curly bracket of the if. So the if is kind of starts with a curly bracket and ends here. If statements sometimes have a then. You probably, of course, studied this before, either in another course or the first part of this course. If you'd have an else, you would type in else, and then you would fill in here whatever would be under the, if the mouse has not been pressed. In this case, if the mouse is not pressed, we don't do anything. So we don't write an else statement. Now, there's something very useful in P5, which is tidy code. Tidy code just organizes the code a bit neater. So, for example, anything which is under the if statement gets indented, right, so that we kind of see the nesting. And actually, this little triangle here allows us to even hide whatever is nested in any nesting curly brackets. Okay. Now, if I press play again, note that you need to press play stops and plays again, or you just stop and play is also possible, or you can just run, which is in command enter in Mac computers, but similar kind of shortcut in PCs. And so now when I move the mouse, nothing happens, but if I press and move the mouse, then something happens. So that is quite interesting. So the if statement is working correctly. Now, what if I want that when I press the mouse, the circle appears and I want some noise to occur, right? Well, we have mainly two ways to create sound in P5. One is to create sounds through code. The other is to load sound files, MP3s, WAVs, any sound file, and then play them back. So in this first exercise, we will simply create an artificial sound. So to create an artificial sound, it's useful to look at the P5 sound. So P5 sound is a library inside. It's the first library that appears inside P5, and it's quite an important library. So you can also go, when you're in the reference, you can simply, there's a shortcut immediately there which takes you to the P5 sound library. So when we want to create artificial sounds, oscillator is quite an important method. So oscillators are waves that are created artificially, and that can be mapped to generate sound. So as we saw in the kind of theoretical lecture, sound is basically a transformation of sound pressure over time, and you can change the frequency of that, and oscillators make that change occur with a certain behavior, with a certain pattern. So for example, in this image here, we can see the first type of oscillator is a sine wave. It makes this kind of bell kind of shape going up and down smoothly. The second oscillator is a square wave. The wave basically has the shape of a square, right? So the ups and downs, the sides of the ups and downs have all the same shape. So here you have a triangle shape. So the wave of the sound, the frequency changes go up and down in a geometric manner, in a linear manner. There's no curves, everything has an angle. And the Sawtooth oscillator, you have a ramp going up and then suddenly going down and then going up again and then suddenly going down. So this is kind of a sawtooth. And then the last kind of wave type is noise, is a random oscillation. It's not properly an oscillator, a typical oscillator, but it's a random noise. It's called a noise. Okay, so let's create a sine oscillator. So how do we create an oscillator? So we need in JavaScript, we create variables with the keyword let or var, and then we declare the variable. So an important thing to know and to mention, variables in JavaScript or many other languages, we need to pay attention to the scope of the variables. So if we are going to use a certain variable in both setup and draw, or more than one function, let's say, we need to set the variable before, at the beginning of the code. We call this the header of the code. And that makes the variable global. If a certain variable will only be used in, let's say, the setup or the draw, we don't need to declare it globally, we declare it locally. But in this case, I will declare it globally because I want to set up my oscillator and then I want to draw it, okay? In the setup, we're going to say what type of oscillator it is, for example, sine. And then in draw, I'm going to change the sine wave, okay? So I create a new oscillator by saying let osc. You could call it anything here, basically. You could call it my osc or nice osc or whatever you want to call it. And here I could say osc equals, no, I'm just following the reference, right? To create a new oscillator, you say osc equals new p5.oscillator and then sine, where sine is the type, and you can have also, you have sine, which is default, triangle, sawtooth, and square, and you have quote marks. So that's what I'm going to do. I'm going to say osc equals new p5 dot oscillator. Sorry, oscillator has a capital O, oscillator, and then you specify the type, for example, sine. Okay. Great, we created the oscillator, but nothing will happen now. We need to play it. We're just creating the oscillator, but we need to play it. So to play it, we start we start the oscillator and we define a frequency for the oscillator. So if you look here in this example code, you see that we are creating we are attributing a frequency to the oscillator, and then we are starting the oscillator. So we're even going to do a simpler exercise than this one. Great. So let's say that we change the frequency of the oscillator here on setup. We can say osc frec, which is the frequency. Let's put here kind of a standard frequency in the middle of the frequency range, let's say 440, for example, and then osc start. Okay. So what happens now? So you'll hear a sine tone playing back, right? Okay, so far so good, but this is not really interesting. I want to hear this only when I press the mouse. And when I release the mouse, I don't want to hear it anymore. So then if I want to start and stop, depending on the mouse, I need two more functions here. I need function mouse pressed, and then I need function mouse released. The function mouse pressed happens, so mouse pressed happens when you press the mouse, and mouse released happens when you release the mouse. So you actually need to create this function manually, mouse pressed, and then something something. So I'm going to do that. Function mouse pressed, and then parentheses open, parentheses close, curly bracket open, and the curly bracket close. And in the middle of this, I'm going to say osc start. So now I don't need this osc start in the setup. And then on mouse released, that's function mouse released. Same thing, same structure. I'm going to say osc stop, right? So let's play it. So now we only hear the sound when we press the mouse, right? So far so good, but it's a little bit boring because the frequency doesn't change. What if we map the frequency to the mouse X? So that could be quite interesting. Then we have a frequency going, for example, from 0 to 400 in X. So I can establish that the frequency then can be calculated not in the setup, but under mouse pressed. We can say osc frec mouse X, for example. So let's hear what happens now. Great, this sounds good. It's just this range here, which is like the first 100 hertz, I don't really hear it because our speakers are not very good at, unless you have subwoofers or very big speakers, our speakers are not good at retrieving that frequency range. So to do so, I could add, for example, plus 100, so that instead, sorry, not inside the frequency here, mouse X plus 100, so that instead of going from 0 to 400, which is the width of the screen, it goes from 100 to 500. So let's play it back. Great. So this sounds a little bit better already. So to wrap it up, I could play with amplitude. So we can set a frequency of a sound, but we can also set the amplitude, which is the volume of a sound. And the amplitude goes from 1 to 0. So actually we can see it here. Amplitude goes to 0 or 1. So how do we modulate that amplitude? Let's say that I want to map the mouse Y. So I've mapped the mouse X to the frequency. What if I want to map the mouse Y to the amplitude? Okay, let's say osc.amp. Now, to map something, we have a very useful, we're going to use it a lot, function in P5 called map. It translates a range of values into another range of values. And map goes in 5 parameters. Let me show you in the reference. So there's the value, the initial value that you want to map, and then where it starts and where it stops, what is the range of that value, and then what you want to output, what is the output value that you want. So for example, in this case, the value we're mapping is the mouse Y. where it starts in 0, where it ends in height, which is the size of the screen in the y axis, and then the start and the stop of volume 0 and 1. So let's do that. Map. What do we want to map? Mouse y. Where does mouse y start? 0. Where does it end? Height. What are we mapping it to? To amplitude. Where does it start? In 0. Where does it end? In 1. Great. So let's try it out. Sorry, I forgot the parentheses. I closed the map, but I didn't close the amp, the parentheses, you see. So I had an error there. So what we have here? It's loud, as loud as it can be in the bottom, very loud in the bottom, and then silent on top. Maybe it could be more intuitive that it's louder on top. If that's what you want, then you have to swap these around. So the height needs to be the first value and 0 the last value. That means in here it will be the minimum, in here it will be the maximum, right? That's it. So that's it for this exercise. I can demonstrate the other oscillator types, triangle, for example. Square. Then you have Sawtooth. And if you want noise, then this is not a typical oscillator. That will be simply noise. In the sound, sorry, let me go to the sound reference. Here we go, so noise. So it extends, it's not a typical oscillator in the sense that it extends the oscillator class. So let's create here a variation of that, because maybe we want to come back to this one. So let's say that osc equals new P5 noise. Now, noise doesn't have a frequency. It's just a random sound. So basically it's just like TV static, right? So if you want to go back to our oscillator, I can comment out the noise and then decomment the frequency, and now we're back to our Sawtooth. And I remind you of this image where we have our different, oscillators, the sine wave, or sine, the square, triangle, Sawtooth, and noise. And that's it for exercise 1.